Welcome to the latest Silicon Valley Redis meetup. Today, myself is Drew Krieger, the Developer Community Manager here at Redis Labs, and we are having a new security features on Redis 6 with our Security Product Manager, Jamie Scott. So without further ado, give it up for Jamie Scott.
Thanks, Drew.
Thank you.
So Drew, when you invited me to do this meetup about a week ago, one of the first things that we said was, hey, what about this virus that's going around? And today we had a meetup and we decided to change it to a live stream just because at the end of the day, safety is our first priority. And safety is a good introduction into the new security features within Redis 6. So first, the Redis 6 release candidate 2 came out this morning. And we're really excited about that because it's actually added an additional logging feature called the ACL log. But more on that to come. So the goal here today is to describe to you our 3 primary use cases of ACLs, and then teach you a little bit about TLS, which we're going to be using, and demonstrate how you use TLS within Redis today. So we've implemented 3 primary features within the Redis open source community, and we're really excited about these. First is the ability to use multiple access control list users. So in traditional databases, you're very used to having the concept of multiple users. However, in Redis, prior to the 6.0 release, we've relied specifically on shared secrets. And that is a paradigm shift within Redis. The Redis ACL feature will also give us the ability to restrict commands and restrict the key space. And for those of you who are less familiar with Redis, Redis is a key value store, and your ability to restrict key space is the equivalent of restricting a row within a SQL database. We also offer out-of-the-box encryption, and this is really exciting to me because one of the first things I heard when I left my past role was, what would it mean to the Redis community if we as an organization and Salvatore and the rest of his team implemented TLS within Redis open source? And I thought long and hard about that. And maybe 2 weeks after I started, we announced that we were doing this in the open source community. And I got ridiculously excited. So without further ado, first we want to talk about access control lists. So within Redis, you have the ability to operate commands and operate keys, and also have the ability to operate on categories of commands as well. So the syntax for Redis is the ACL set user command, and that command is how you are going to be able to provision users. The syntax is ACL set user on or off, the username. If there's a reset directive, you can completely reset that user. The passwords and the commands, command categories, and the key restrictions that you want within the user. And we'll demonstrate that a little bit later. On and off changes the user state. We have directives to add and remove both clear text passwords and hashed passwords. It's important to note that these are not passwords in storage. What they're doing is how you operate them on the command line. So all the passwords will be secure in storage, but on the command line you have the choice of whether you want to add and remove password hashes or clear text passwords. And the hashing feature is really powerful because it allows you to pass in the password securely if you're, say, logging it in the bash history. And it also allows you to add and remove passwords without actually knowing what they are. And that prevents administrators from sharing them and reduces the risk of having a password potentially compromised. You can also add users with no password, as is traditional of many databases. There is a potentially insecure default. There's also the ability to restrict on keys, and this is done with the tilde operator. The tilde operator has the ability to whitelist keys. And I think that's really powerful because by whitelisting keys, you can specifically specify whether an operator of Redis has access. And this is powerful for various use cases, which we'll go into next. But some helpful tips. You can add categories with the @ symbol. We've got categories such as read, write, dangerous commands, which we'll go into in a bit. And also, Redis Enterprise will abstract many of these features. So first, how do we do key restrictions if you're using a prefix? And that's what you're doing. So traditionally in Redis, you use an object, an identifier, and potentially an optional name to define the key. And what ACLs does is it introduces a potentially new concept. ACLs gives you the ability to prefix or namespace your keys to assign access levels to them. So ACLs, their primary use case is to enable operational security. However, you can get very granular in your operational security by bringing it into the design process and shifting security left. And that design process is based fully around the namespacing concept. Now, given you can do namespacing based on an object type if you're using a standardized format. However, one of the things that I believe will be really helpful in scaling this is the concept of namespacing throughout Redis. So I want to do a quick demo, but first I want to show you some potential concepts. So as you can see here, what we're doing is we're going to namespace based on a data classification. And those data classifications are secret and public. We're going to have a couple users who either have access to secret keys, they have access to public keys, and these are not to be confused with actual public key infrastructure, but we will go more into TLS in a bit. We'll also have an admin user and several users with ACL rules on specific commands. So let me switch over to the terminal to show you better. So we're in Redis now in the Redis CLI. And if I do ACL who am I, you can see that I'm already logged in as the administrative user. Now, this is a new user that I've created called admin, and it is not the default user that comes with Redis. If I use the ACL list command, what you can see is the user's permissions and that have been defined. So as you go through, you see the username, whether it's on or off, the actual credential hash, then you see the permissions that are defined. So if you look at the user admin, you can see that we've removed all permissions. So the @all category is all commands. We've given it dangerous commands and we've given it administrative commands. If you look at the service account 2, which is the user 4 in the slide, you can see that it's on and it only has access to keys with the namespace of top secret. And you can see that highlighted here. We've also removed all commands except the get and set commands because those are the only operations on keys that it will need to perform. So let's demonstrate how to add a user now. So I'm going to use ACL set user, and I'm going to create the user Itamar and turn him on. I'm going to give him the password, and I'm going to give him the ability to use the get command and the hget command. Further, I'm going to give him access to keys with the secret namespace and the public namespace. And that is the basic syntax of adding a user. So now let's first look at our keys. I've pre-populated a database that's intended to be a retail database. So the first thing you can see is that this user, Itamar, has no permissions to actually run the command scan. And that is intended, although totally unintended for purposes of this demonstration. So let's do this and add the scan command for Itamar. Okay, guess not this time. So auth, and who has administrative commands? Let's go to the, oh, that is because I'm not running as Itamar. So let's authenticate to Itamar. And let's look at the first 30 keys within this database. So you can see here that we've namespaced all of our keys with top secret, public, and secret. And Itamar has access to the secret keys and the public keys. So first, let's look at the type for secret users 5. And you can see here I also don't have permission to use the type command. But I have access to hgit and the public key. So I will do hgit public order 1. So you can see here, we've run a lot of failure events. So, yep, I need a charger. Oh, thank you. And we can see these failure events with the ACL log feature that we just talked about earlier. And the ACL log feature will show that I'm failing to run scans as the admin user. It'll also show that as Itamar, I've tried to run the type command and failed. And the value add of the ACL log feature is that it'll show all failed authentication events and it'll show all failed access events. And by design, we want to be able to show these failed events so that people can monitor for security. And it also helps greatly with operational complexity, because if you're wondering why you failed, you can look in this event and understand what is failing in your application and start to troubleshoot why. But let's move on. So now that we've done a lot of failure, let's log in as the service account user. And let's do an hgit all for secret users 16. And success. We now have access to one specific record. And if you remember from before, the service account user had access to hgit all command and the secret, but it doesn't have access to public. So I will go to order 1. And you can see here that I don't have permission to this specific key. So you can restrict access to keys and you can restrict access to commands. But with specific users, you can also get to very granular access controls. With categories like read and write, you can use things that are broad and scale. But if you want to get granular, you can use specific commands. So now let's talk a little bit about TLS. And TLS is a complex subject. So for those of you who don't know TLS well, What I want to do is I want to help you understand that it's important to understand there are many options. So Redis now comes with out-of-the-box TLS, but before, Redis didn't have it. So we would use S-tunnel or client-side encryption in order to establish this. We even used IPsec when we were in cluster mode occasionally. And now we have out-of-the-box encryption that we can leverage. So to understand TLS, we need to establish a common language. So first, you have a certificate. A certificate is your stated identity. Hi, Elena. We have a CA chain, and that CA chain is a web of trust. So a certificate is defined in 3 chains of certificates. You have a root certificate, which then signs an intermediate certificate. Afterwards, that root certificate is typically stored in a location that is never looked at again until it's next time to sign an intermediate. You then have your intermediate certificate, and this is typically called an issuer. And that certificate is used to sign the certificates that are generally used by web servers and database servers today. We also have a public and private key. A public key is something that is shareable by everyone, and a private key is to everyone. And a private key is something that is secret just to you. And users who want to send communication to you sign data with your public key, and only you can decrypt it using your private key. The math behind that is a little bit out of the scope of this talk, but if you'd like to learn more, you can search RSA encryption. We also have TLS protocols, and TLS protocols show how you establish a handshake. It also defines a little bit about the underlying algorithms or cipher suites that are used. So let's go into the anatomy of what a TLS handshake is so that you can understand a little bit more about some of the configuration directives within it. Within Redis server, a client's always going to first initiate a connection with a client hello. And that client hello is going to include the TLS protocol that the client wants to use, along with supported cipher suites. And those cipher suites are really just a set of 4 different algorithms that are used to establish communication. Then the server will respond with a server hello. That includes supported cipher suites that the server would like to select, and the TLS protocol the server would like to select. And this typically defaults to the strongest protocol and cipher suite available. You also have the server certificate, which is configurable by you. The actual Redis client certificate request. So a client certificate is optional as well within Redis. And if you're using specific algorithms like Diffie-Hellman, you can also request a key exchange. The client then comes back, and if using Diffie-Hellman, uses the client key exchange, and then sends something called a change cipher spec. And the change cipher spec is simply a flag that says we are now using a secure connection rather than an insecure connection. It'll send its client certificate and its CA chain so that the server can verify that it trusts the client certificate. And then the server will send the change cipher spec flag back. And then you have a TLS connection. So what can you do in TLS 1.3? Because TLS 1.3 is also a new feature within Redis. Well, TLS 1.3 comes with all of the same or similar directives, with the exception of Diffie-Hellman. And what TLS 1.3 does is drastically improve the performance of initial connection by removing a full network hop. And it does that by sending more data up front on the client and sending more data in a more efficient way. And TLS 1.3 also removes many legacy cipher suites. So if you're an enterprise looking to use open source Redis and are very used to security scans, going in and flagging specific cipher suites as insecure, TLS 1.3 removes that problem for you as it stands today. There could be security vulnerabilities in it in the future, but those have yet to be discovered. So what I'd like to do is talk a little bit about TLS best practices and then go into how Redis TLS actually works. So first, what are some cautions with TLS? Because TLS is one, new to Redis, but also two, it can be complex. So first, TLS protocols need to be supported by both a client and a server. If the client or the server both don't share a cipher suite or a protocol, those will fail. The cipher suites also need to be fully supported. And if you prefer the server ciphers, connections may not be allowed. It's also important that if you support specific clients, that those clients might not use the specific TLS protocol. So TLS 1.3 is the emerging standard, and it's got fairly wide adoption. But there are still clients in the industry today that don't support this, and it's important to test every time whether your client supports TLS 1.3 before you configure it. But that said, TLS 1.3 is an emerging best practice within the industry. Some best practices that some people use when trying to secure Redis are using mutual authentication, using TLS in a cluster if they're running in cluster mode, and also preferring server cipher suites. Now, one important thing to talk about is TLS isn't used for every use case. If you're trying to protect some sensitive data like someone's social security number, you're likely going to use this. But if you run a site that generates regeneratable memes, TLS may not be right for you. So it's important to understand that you shouldn't always try and secure all of the things. And while security is important, it's important depending on what you need it for. So let's show you a little bit about Redis server and TLS in action. So back to the command line. So one of the really important things when it comes to TLS with Redis 6 is that Redis must be specifically built for TLS. And this is as simple as using the make command when building Redis with build TLS equals yes flag. But that said, our environment's already been built with TLS. So first, let's start. So Redis CLI is now TLS compatible, and that's something that's new. To use TLS, you have to use the TLS flag, and you have to send it a certificate. That certificate is used for client authentication, as we described in that handshake. You have to send it the key, just so that the client can establish that connectivity and decrypt traffic. And you have to send the CA certificate to the server, because the server is going to verify the CA certificate always. And let's test that now. So you can see here, I've established a TLS connection with Redis. But if I exit that and use a different file, so say redis.crt, oh, I actually have the exact same certificate there. But you can see here that we can't negotiate a TLS connection because there is an invalid CA directory. So one important thing to note is TLS will always be verified by the server today. And let's go through the process of establishing a TLS certificate though. So first, let's create a new key for Redis. And we're going to call this Redis key. We're using the OpenSSL command to generate a 4098-bit key. We are then going to create a certificate signing request, as is customary. So we use the Redis key to create our CSR. And we're going to create a CSR in the US, in the state of California, in Redis Labs. And let's just fill out random information for the rest. And we now have a certificate signing request. We can then take that certificate signing request and sign it for use. So what we're doing here is we're taking the CSR here, we're signing a new certificate called Redis certificate, creating it for 366 days, and we are further using the Redis key to sign that we just defined. And you can see the information I input here. And we've now created the Redis certificate. And we've done that all in the proper directory. So I've already set up our redis.conf file, but let's look in the redis.conf file to see a little bit more about the setup that this takes. And let's go through some of the directives that we discussed earlier. So first, within Redis, you can define the Redis TLS port. And that can be any open port on the operating system. We have it to the default Redis 6379 port today, but that can be changed if desired. You can see here that the Redis certificate and the Redis key are going to be used by the server for server authentication. Optionally, you can set Diffie-Hellman parameters if you choose to use Diffie-Hellman. I'm not going to set these here because I'm going to use TLS 1.3, and TLS 1.3 doesn't currently support. You can then create a client certificate in CA. That client CA will be used to verify the certificates that you send. It's important to note that you could also use a self-signed certificate in order to validate your client authentication. And you can do that by simply making the CA certificate here the actual self-signed certificate. Because a self-signed certificate signs itself, it is its own issuer. And you can define a directory where your CA files are defined as well. So Redis by default is always going to use client authentication, but you can disable client authentication by enabling the TLS auth clients directive and setting that to no. And encryption can also be used not only for client to server communication, but for replication and within the cluster bus. So here you have the ability to replicate your shards between servers and nodes in the cluster, and the ability to encrypt traffic between the cluster. And I think that's a really powerful thing for some of the people in the open source community who are using sharding and running in cluster mode with sensitive data. You can also define your TLS protocol. Here I'll use TLS 1.3 for that performance improvement we discussed, just on the initial connection. We're currently measuring what that actual performance improvement is. And you can set your TLS ciphers and cipher suites. So the difference between TLS ciphers and cipher suites is not what you would traditionally think. The only difference between these two directives is that one is used for TLS 1.2 and the other is used for TLS 1.3 only. And the reason for that is because OpenSSL 1.1.1 currently today, as it comes with TLS 1.3, is a huge difference from older versions of OpenSSL that don't support TLS 1.3. And we've done that in support of backwards compatibility. And last, you can define server ciphers, and if you would like to prefer them. And what this does is it ensures that your client cannot dictate what cipher is going to be used, but that the server can dictate that. And this is generally considered to improve security by preventing the client from downgrading your ciphers. So, as we look at Redis as a whole and as it evolved, one of the things that I would just like to say is thank you to the open source community. There were a ton of people who helped in Redis 6, and while a lot of companies like Redis Labs who follow Redis, we think that this is one of the most powerful releases and is a huge opportunity for our industry and Redis open source adoption. So thank you to Salvatore and to the rest of the contributors in the open source community. And now I'd like to open it up for a few questions. Drew? Sweet. Well, coronavirus has officially made this be a live stream. Is there anyone on the YouTube channel?
Thank you, Jamie. There's currently no questions on the chat. If anybody on the chat would like to ask a question, please do so now. Let me double check here. While we wait, I do have to mention, if you do want some more content like this and other forms of open source community Redis content, please head to redislabs.com/community, or TED Talks would be redislabs.com/tech talks. So yeah, I appreciate everything. That was great. Thank you, Jamie.
I appreciate it.
Thank you.
Are we off now?
Oh, I do have one question that just came in. Sorry, are we still live streaming? It says, what about key management?
So when you say key management, what are you referring to, Sunil? So there is the ability to rotate the keys. That can be done through OpenSSL or through your own. What that would require is you to create a key and define that key's location in the redis.com file. One of the things that I think every security professional will also recommend is to restrict that key file down to the user and group, so that you say chmod 400 or chmod 640 it. But when you say key management, I'm not sure what you're referring to.
Can I bring my own keys?
Yes, you can.
Okay. Great. And the next question is, will you be able to share the slides?
Sure.
Great. We will post the slides on a Google Doc and then on a Google file, and we'll share that within the YouTube. All right. Is there any other questions before we sign off, everybody? Let's just double check here. There's a little lag, so let's give it one more second here.
What we get for using your phone for questions, Drew.
Yeah. What are you most excited for within Redis 6 beyond security?
It's a really great question. I am our security product manager, so I have to apologize for being overly excited about security. I'm really interested to see how client-side caching evolves. Mm-hmm. Right now, that is currently being worked on. I don't know. I'd have to think about that.
Okay. Well, I do not see any other questions. I appreciate everyone's time today. Jamie did a great job. Thank you. Appreciate it. Thank you.